Quick question. How do you look for something when you're not sure what it looks like? That's not philosophy. That's one of the biggest problems in space science. Right now, when we search the universe, we're basically saying, if it looks like Earth, great. If it doesn't, then good luck. We've built incredible machines, telescopes that can see billions of years into the past, rovers that drill into alien soil, and sensors so sensitive that they can detect a whisper of gas light years away. And yet, here's the uncomfortable truth. All of our instruments are designed to confirm what we already expect. Oxygen, methane, water, radiation. That's like searching for a new species, but using a list of animals you've already named. Every sensor we've ever built answers one question at a time. How much radiation? Is there oxygen? What's the temperature? Etc., etc. But the universe doesn't work one factor at a time. In space, everything happens together. Microgravity plus time, radiation plus chemistry, pressure plus randomness. Machines isolate variables, but life doesn't. Life experiences everything at once, and that difference is important. So here's the idea, and yes, it sounds slightly unhinged at first, but what if, instead of only sending machines into space, what if we sent life itself? Not to survive, not to colonize, not to be heroic, but to sense. I'm not talking about astronauts, animals, definitely not humans. I'm talking about simple microscopic organisms, bacteria, yeast, spores, life so small that millions fit in a grain of sand. Engineered not to explore, but to react. We genetically engineer these organisms to respond to stress. For example, they may change color, they may glow, their DNA shows signs of damage, and their proteins break. And here's the key idea. If something damages them, then that's not failure. That damage is the data. But why biology? Because life is the best sensor system we know. A radiation detector will give you a number. Radiation level 10, high. But a living cell tells you that this radiation destroyed my DNA, disrupted my metabolism, and stressed several systems at once. One gives you measurements, the other gives you consequences. And when exploring the unknown, consequences matter way more than numbers. But you may be asking, don't scientists already know the science of life? And yes, but based on Earth. And that's exactly the problem. All of our biosignatures assumes that life behaves like us. But oxygen, the thing life depends on, used to be toxic. Early life hated it. And so, if we searched for Earth-style life back then, we might have missed life completely. And so, instead of asking, does this look like Earth, we should instead ask, what does this environment do to life? That question still stands even when our assumptions fail. Another question is, isn't it still predictable, even as we are engineering the organisms? Short answer, no. Long answer, still no, just smarter. Yes, we engineer known response signals, but we cannot predict how stresses combine, how damage builds over time, how unknown particles interact, or what breaks first. Machines simulate environments, but life experiences them. And reality is much messier than models. So, how does this actually work? 1, we choose safe microscopic organisms. 2, we engineer these organisms to have visible and clear stress signals. 3, we seal them in contained systems. 4, we send them out into space. 5, we use cameras and sensors to observe these microorganisms. And 6, we analyze the patterns of damage. We're not asking, did it survive? We're asking, What happened to it? And that's a much better question. So let's quickly talk about ethics. No animals, no release into space, no contaminating planets, and no sci-fi nightmare. This is sensing, not colonizing. For decades, we've asked, can life survive in space? But we should instead be asking, what does the universe do to life? As the universe has been answering that question the whole time. We just haven't been listening the right way. Every sensor humanity has ever built is designed to look for a question we already know how to ask. But life doesn't ask questions. Life responds. And in those responses are signals that we don't yet have a language for. So we truly want to explore the unknown. The answer may not be building smarter machines. It may be letting life itself show us what we've been missing. Thank you.